Okay, class. So we've looked at some of the central tendency stuff now. So now the question is about the graphing. Okay, how would you know what kind of graph to make? And so what I've done is actually shown you a slide from the textbook that I had created. And I'm actually going to go down to about page 86 or so. That's where I actually get into some of the stuff that you're interested in. Just as a reminder, since I got it up here, nominal provide names or labels for stuff. Ordinal, you have order. Interval, you have some kind of attributes. Unit differences become meaningful. You have unique, the same difference between values. In a ratio, we have a non-arbitrary zero. But here are some of the common graphical displays that you'll see for categorical variables. Okay? You have a column chart, a bar chart, and a pie chart. Now, a column chart is what we would commonly refer to as a bar chart. It's literally a bar chart with the bars going up and down. The bar chart is a bar chart going from left to right. And the pie chart, as you know, looks like a pie. So the question is, when would you use which? So if you want to compare the magnitude to the size of groups of data, you'd look at the bar chart or the column chart. If you want to look at the proportion of each group or compare the one slice to the whole, you'd use a pie chart. So here is kind of just some more information about the column chart. You'd use this to compare the relative magnitudes. You can change or point your audience's attention by doing something to the bars to make them larger. You can do an outline of the bar. You can change the color, make it bold, or change the pattern. This makes your audience's eye go to the one that stands out. So if you have a number that looks like an outlier, looks like it's a big improvement in your curriculum design, in your assessment, then you want to actually look at that and say, hey, I'm going to change this bar. So your eyes would actually go to the bar. Okay? Now, it's more ideal for have the fewer bars as possible. Okay? Because once you get a whole bunch of bars, it's really hard to distinguish between them all. So if you imagine doing a bar for every state in the union, you'd have 50 bars on one little 8.5 sheet of paper, and you really couldn't distinguish the difference between numbers 23 and number 36 because the bars are so close together. It's also easiest if you put the bars in some kind of order. Most commonly, it will be from highest to lowest. Sometimes you see them in alphabetical order, but my preference would be from highest to lowest or lowest to highest so that the audience can actually interpret what it is you're trying to tell them. Okay. Here's an example of a column chart. This is actually two dimensions. You have the quarter, which tells you exactly when the data was collected. And you also have these different organizations in the IRS, wage and investment, small business, self-employed, and large business and international. And the statement is how many students did you train over the last quarters or whatever. And you can see that each color represents a different organization. You also see third quarter, this large bar suggests that in W&I they train more than previously. Okay? But in each of these cases, you can look at the bars and find out who trains most. So typically, according to this data, LB&I trains the most because I'm comparing this to these two. I did it again for the second quarter. It's the same for the fourth quarter, and it's almost the same for the third quarter, except the W&I actually has a way for the W&I in third quarter actually trained more. Now this could have been because they had some hiring blitz where they're bringing new people on board and they had to kind of catch them up to speed or a refresher course or whatever. But you can clearly see that this number for the third quarter is different than the others. Okay? That's one of the benefits of having a column chart. If you have it made correctly, any differences like this will kind of stand out to you. Now, for the bar chart, that's pretty easy to explain. It's a column chart rotated 90 degrees. So it would look kind of like this. It's the same data. It's the literal same data. The only difference is the bars are going from left to right rather than up and down. Again, you'll see W&I far exceeds the rest of them in the third quarter. Okay? So you can even look at this to answer questions like, which business unit trained the most? We already said that, W&I. How many did they train in the fourth quarter? You can read that off. About what percentage were trained in LB&I in the first quarter, and about what percent were trained by SBSE in the second quarter. And so you can see that for the first question, W&I, largest. Okay. For the second question, you'd read off, well, it's about 20 people who they trained in the fourth quarter. Third question, you'd have to look at the actual bars of the first quarter and kind of do a relative comparison as to how many fell into each bin. So there's about 45 for LB&I, there were about 30 for SB, and about 20 for W&I. So when you calculate those are the total that were given for LB&I for the quarter, and then you divide this by 45, and you see about 47% of the people in the first quarter were trained by LB&I. And a very similar thing happens for SBSE for the second quarter. About 35% were trained in SBSE in the second quarter. Now, when would you use a pie chart? You'd want to use a pie chart when you want to look at the proportions of each group. But remember, it is a pie, so the percentages have to equal up 100%, and it's 360 degrees. So if you thought about it in terms of arcs, the sum of the arcs have to equal 360 as well. Now the problem with the pie chart is it is difficult to compare the different sections of a given pie chart when there are a large number of slices. So my recommendation is similar to the bar chart. Don't use a pie chart when you have more than 4 or 5 slices in a pie, because then your eyes become deceived as to which pie slice is the largest. Also, it is difficult to compare across pie charts because you'd have to visualize from one chart to the next, and your eyes have to keep on going back and forth to try to compare them, rather than if they were on top of each other, that comparison isn't needed because you can literally see which of the charts were bigger, which of the slices were bigger. Okay? And again, the pie chart is most effective when you're comparing one slice to the whole and not to each other. So here's an example. I have a pie chart of pie preferences. And one of the questions is, what percent of survey respondents preferred cherry pie? If 1,000 people responded, how many preferred pumpkin? And what percent preferred a type to begin with the letter P? You can see that 23% preferred cherry based on the size of this pie here. You can also see that 30% preferred pumpkin. But once I have a percentage, I have to multiply that by the total number that was surveyed to get the estimated number of people who responded to pumpkin pie, which will be about 300, which is literally the percentage times you're in. And then the question is, which one preferred some pie that began with a P? If that's the case, you just have to look at which ones began with P and add them up, pumpkin and pecan. So 30 plus 8 is 38%. About 38% preferred a pie with a P. Those are common for categorical data. Okay, but what happens if you have quantitative or scale data? When you have scale data, you'd want to use a histogram or scatter plot. Now, I don't have that in this particular notes here, but what we'll do is actually transfer it to SPSS, and you'll see what we're talking about. So here's your SPSS file. Okay, I have some categorical data, I have some scale data, and let's say, for instance, I wanted to say, give me a pie chart of the people who have retirement accounts. And let's say you got this data cold, you don't know what's going on, you just happen to find it, and you pick it up and you analyze. You want to do a graph, but we're going to do it the back way. So we'll go to descriptive statistics, we'll go to frequencies. I don't want the frequency table, that is, so I'll put over retirement account, But here under charts, I'm going to click pie. This will give me a pie chart. And I can tell it to either give me the frequency of it or the percentage. In this case, I'll leave it as frequency. But then you click continue and click OK. When you do this, you'll find something that may be kind of interesting to you. Your data looks like this. So you have a little bit more people said no than yes. Now it's important to realize that this data is the weighted data of your analysis. If you forgot to put the weight on, you're going to have a different looking pie chart. And I'll show you what that looks like. If you go to data, weight cases, and let's use all the cases, and we try to rerun the pie chart, you'll notice that it's no longer out of 1051, but it's out of 20, because we only had 20 rows of data. And what's worse is that we actually had 50% yes and 50% no, so your pie charts are even down the line. That doesn't really tell you anything. So it's very important to make sure you have your weight on if you need it. So I'll put my weight back on, and no pun intended, and I'll also look at a different variable. Okay. So we have weight back on, and I want to look at the pie chart for gender. Okay, so I'll take retirement account off, look at gender, click OK. And here you have female and male. You can see most of the people were female. All right. So that's how you make a pie chart. I can click on the pie chart, get to more detail if I wanted to change the way the pie chart looked. My thing is in the back somewhere. I can get to it. Okay. I can change the way it looks. I can change this color if I wanted to. I can explode out. If you just click on that one thing, I can explode out a piece of it if I wanted to. All right. I can change the color. Make this red. I want that piece red, for instance. All right, close that. I could take off these words down at the bottom. If I don't like cases weighted, I could delete these words. Okay. I could even show the amounts of each group if I wanted to. So that's a lot of analysis that you can do just on this show data labels, for instance. You can show percent. It's 3941 or 6051, and then I'll just get out of this. So those are pie charts. What about bar charts? The bar chart is actually very similar. I can do data. Well, I'll just go back to where we were before, except this time, rather than do the bar chart, rather than do pie chart, I'll click bar chart. Click continue. Click OK. Here's my bar chart. Now, what they're calling bar chart, as you see, is really a column chart, but you can have the distribution of females to males in terms of frequency just by using this bar chart. We can double click, we can change the colors the same way we did before. Okay. And also, let's say I was interested more along the lines of one of the quantitative numbers. If that's the case, you'd have to use a histogram. But before we do a histogram, let's show you how to do this using this graph variable. The graph label, I'm sorry. Go to Graph, Legacy Dialogues. You see you can do a bar chart here, you can do a pie chart here, a line chart. Here I'm just going to do the bar chart. And I'll do bar here. Simple is fine, you can only have one set of data. Clustered if I'd have multiple sets that I want next to each other, much like that training data set that I showed previously. And stacked is if I wanted them on top of each other so that the sum would equal 100%. So simple is fine. I'll click define. I could give you percent of cases or number of cases. In this case, let me give you the number of cases. Okay, and click OK. So I want this for gender, so I'll put that over here. I'll put that over there and click OK. Now you can use other variables other than the mean, other statistics other than the mean, but I think we are good on N. The N's fine. You click OK, and what you'll see is that you created the same bar chart you created before. So you can use this graph, legacy dialogues, or you can just go back to analyze frequency and go to charts. Finally, what if we wanted the data for the salaries? Okay, now our salaries, we go back to here. Our salaries are numerical data. Okay, so looking at a chart, a bar chart with 20 numbers would not be very pretty because you'd have 20 bars. Okay, looking at a pie with 20 slices also is not very pretty because you have 20 slices. But what we can do is actually look at the histogram of the data. So here we would have to do analyze, descriptives. Let's go back to frequency. In this case, I want the salary. Okay. And I also, just because I want to get the mean, median, and mode spit out as well. Now, why not give me a standard deviation and variance? I can click as I go along just because I can. Okay. And then go to charts. This time I want the histogram. And if I thought that this was normal data, I actually could put the normal curve on top of the histogram. If your data is normal, this is a visual way to look to see if your data is normal. If your data is normal, it should pretty much flesh out to the picture you see for the histogram. So I'll put it on there and just see how close we come. Continue. I don't want to display frequency tables, and click OK. What you notice is that it again gives you the output for your mean, your median, your mode, your standard deviation, and your variance. And here's the histogram. Okay. You see you have a whole bunch of data here bunched up between 0 and 100,000. And you have a couple out here at 940 some odd thousand. So this would be considered a skewed data set. Why? Because it's skewed to the right, this long tail. And also you'll notice that the mean and standard deviation is also given here on the histogram. Just like before, I could click it, make it more, I could format it however I like to. But let's look at what happens to this histogram if I remove those outliers. So I'll go back here, I'll go to select cases, and let's say I want the ones that do not include the guys who make about $1 million a year. Okay. So, and it's not just one this time, it's going to remove all of the 35 people who made that much money. So they're gone now. And now when I redo the histogram, you'll see a picture that looks more like this. Okay? Now, it's not as spread out, and you notice it doesn't really look like the normal distribution because, number one, there's a bunch of modes here. There's a bunch here, there's a bunch here, a bunch here. There's about 4 or 5 modes here. And if you remember what the data said earlier, it said there were multiple modes. This is what it's getting at. It's not just one hump of this data. There's a hump here, there's a hump here, 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 and here. So the data is not normal, no way, no how. Okay? But at least you can see there's your histogram. So that's how you would do the bar chart, the pie chart, and the histogram using SPSS. Now, I do not think, if I'm not mistaken, that you can do it. Yep, you can actually. You can do a histogram here as well. Click that. Click back salary. And click OK. And what you'll see is the same thing again. So you can use graph and do the same thing as well. This one doesn't have the normal on it because I didn't select it. Okay? Finally, okay, if I looked at multiple data points, if I had 2 different variables, let's say, in this case I have count and I have salary. If I wanted to find out how they look together, I can plot them on what's called a scatter plot and see if there's any kind of linear relationship between them. But in order to do a scatter plot with count, I would have to take off count as my weight. So in this case, I'm just going to look at it as 20 variables. Well, 19 if I leave the filter on. But I can go to Graph, Legacy, Scatter Dot. I can do a simple scatter. That's all we need here. And I can put salary on my Y, and I can put count on my X. I can just click OK. And what this does is actually plot the salary with respect to the count. So each of these dots represent a value. A person had a count of 104 or so, and their salary was somewhere between 12.5 or 12.3 or something like that. And you can actually see this person in the data. If you click them, you can go, you can highlight them, make them different color if you want it to. But here he is. If you go back to your actual data, I have 104, or here she is, 104, 11.5. Okay, that's that person there. So what a scatter plot lets you do is look at the actual display of the data. What you're interested in is whether or not these dots line up with some kind of line. If they line up in a line or relatively close to a line, then we think we're in a good shape to do what's called a linear regression, in which case we can predict the value of the Y variable based on the value of the X variable. Okay, now this one is a little bit longer than the other videos, but we've covered bar charts, pie charts, column charts, histograms, and scatter plots in about 10 minutes. So that's it for me, and I will see you guys shortly. Have a good day.